Hello, we are Group 4 and we are presenting parking system. Here's our agenda. First, we'll talk about the parking lot problem, the current scenario, the objective, the features, the process flow, the process model, the data model, the interface design, and we'll conclude. The current scenario is a typical parking finder can map out the location of the parking lot in the chosen area. The user can view the rates and reserve parking. However, the user do not have the capability in finding the exact location of the parking space and show amount of vacancy in the parking lot in real time. So it takes a considerable amount of time for the user to drive around in a parking lot to find a vacant parking. But our system would be able to pinpoint that vacant location for the user. So our objective is to give a user a system that will enable him or her to find a parking space according to a specific location provided by him, and also enable the user to get all the required information in a common place, such as the parking lot rate, the availability, the ratings, the hour of operations, and they also enable user to find and choose parking space in less time. So our features, the user can interact with the system through the web and also the mobile application. The system has two parts, the sensor at the parking space and the host system. The sensor at the parking space would detect whether the space is vacant or not. When the user parks the vehicle, the sensor would sense the signal that the space is occupied. And likewise, when the user leaves the parking space, the sensor would change the status to vacant and send that information to the parking system. The parking system would then know to whether the space is occupied or not and display that information to the user in real time through the user interface. The user interface can also display other information such as the rate, the review, the ratings, the photo, the hours of operation for the parking lot. Here is a high-level parking space data flow. First, the user accesses the parking system. The parking system would then get the location of the user. The user then drive to the parking space, park the vehicle, and the sensor at the parking space would detect the occupancy, record the start time, and send the data to the parking system. The parking system then would update the space status to occupy with the time and send the sensor information to the parking lot operator. The parking lot operator would then receive that information. So then when the user leaves the parking lot, the sensor would again detect the space vacancy, sends the end time and the status of vacant to the parking system. The parking system then update the space vacancy in the database and send that information to the parking lot operator. Now the operator would have two information, the hours of the occupied time and the hours of vacant time. And if the hours of and if the duration is more than the hours of paid, given that the parking space is a prepaid type, then there could be an alert for the parking lot operator so that a clerk can go out to the parking space and do the needful. Next, we'll talk about the context diagram.
In the context diagram, people want to park their cars before they go shopping or go to a restaurant. Thus, they need a system to provide information about where or when they can parking. It's very convenient for people. Well, the parking lot need to upload the parking space photos, reviews, some special needs, and availability time and member of space. In the use case diagram, the users can search parkings and from the parkings, they also can register and make reviews. The parking lot database needed to upload the infos and update the space availability. In the use case diagram, the primary use case is found parking. Users need to exercise parking systems UIs Then they search parkings and choose the parking lot they want. The list parking space availability will be shown for them. Then they choose a preferred time, and finally they parking their cars on time.
Then we talk about sequence diagram. User can search parking lot by address on system interface by inputting the address and radius. Then parking lot system send data to system database. Database return the parking lot availability and display it to user on system interface.
Class diagram. We design 7 classes. They are user, member, guest, review, parking lot, meter, and sensor. And the user class is a parent class, which contains attributes like latitude and latitude. And the member class and the guest class is a child class of the user. In review table, the user can input a review ID, review test date, time, and photo rating. Our major class is parking lot. User can use methods like find parking by address and by nearby, and get occupy, get meter information, which is relevant to a meters class. Methods like pay in space number and pay in hours. Another parking lot method is get vacant, which is relevant to sensors methods like parking in status and live in status.
In the last segment, we are going to present mock-up interface design for our system. User has an option to register himself and become a member with our system. So this is a registration screen, and the next one is interface design for login screen, where a member can log in to give reviews and upload photos if he wants for any particular parking lot or parking space. This is our main search screen, where user can search by two options. Either he can search by location or he can search by nearby option. In search by location, user has to provide specific information like street address, city, state, and zip code. And in search nearby option, once he clicks the search nearby option, then our system will figure out the current location of the user and will return a result of list of parking lots according to the user's current location. This is a main search result screen for our system, where on right hand side there is a map and the blue icons show the number of parking lots available, and user can also click on the detailed option and get a specific information about parking lots like hours of operation, parking type, whether it is a paid parking or it's a free parking, and number of special needs parking spots in particular parking lots, and so on. This is a very important screen for our interface design, where user can see our parking layout for a particular parking lot. The blue ones are parking space which is occupied, and the green ones are parking space which are not occupied. So user can have a look at the layout and decide where he wants to park his car. In conclusion, by using our system, a user can efficiently look for a particular parking spot according to his location, and this saves him time, gas, and money. And not only users, even our parking owners can take our service and give their customers a better experience. Thank you so much for listening.